So I'm Melissa Mack and I'm working for EDF Energy. So now let's have a closer look to our case study on which is the transfer of a heavy package from vessel to floating offshore wind turbine. I will go through the setup, key result of our model, and also an insight on operability. So the first case we have simulated is the installation of the 330-ton piece of equipment lifted to the floater. As shown on the picture, we can see that the crane is positioned closer to the floating offshore wind turbine and positioned mid-vessel. This arrangement has allowed us to rotate the crane to transfer the package to the floater, and also this arrangement has allowed us to attach tugger line from the crane boom to the package to control the package movement. So the main assumption taken in our model is that we did not consider any wind drag or second order wave forces on the floating offshore wind turbine and vessel. We only consider wind drag on the lifting object. So on the right, as Tanguy mentioned, here's the 244 cases simulated. The wave roses represent all these cases, and for each wave direction, we can see that the lower HS is on the left and the higher HS is on the right, and all the results are presented in this format. So with this setup, let's go through the initial result for the case 1 without tugger line. So in this case, we can see that for either the EDF result on the left or SBM result on the right, we can see that the head C are the most favorable wave direction, while beam C only allowed a few cases to meet the criteria that we have defined, 9 for EDF and 8 cases for SBM. Also, we have noticed that most of the passing cases involve low TP value and low HS up to 1.5 meters. And we know that it's mainly due to the body's natural period of the system, which is 10.5 seconds for the roll motion of the vessel for beam C and around 15 to 17 for the pendulum period of the package, which explain the low success rate for period higher than 9 seconds. Also, as Tanguy mentioned previously, when we did our simulation, we realized that it's really complicated to conclude if the differences between the semi-sud and TLP are due to the floater characteristic or the model hypothesis that we have took. So now let's see how the result changed when we add tugger line. Can you go to the next? Yeah, thank you. So in this second case, we can see that we have slightly increased the success rate when we have added 2 tugger line from the crane boom to the package. We can see that for EDF, 8 more cases has passed when adding the tugger line, and for SBM, 13 more cases has passed when adding the tugger line. Also, we had noticed that the cases that has passed are especially for quartering C, like 315 degrees, for example, and also that we have also increased slightly the success rate for the TP above 9 seconds, but it's only for low HS, which is equal to 0.5 meters or 1 meters. So now that we have reviewed the overall result, we wanted to know the specific criteria contributing to a failed case. So in this graph, we have plot for the case 1 with tugger line, the percentage of failure for each criterion that we have defined. So for this case, we have assessed different criteria. For example, the distance between the tower and the package, the distance between the crane and the package, and the package offset, which is the gap between the landing area and the bottom of the package. And we can see that the package offset is the main limiting criteria, and it's really linked to the package motion and also to the pendulum period of our package. We can also see with this case that some case also fail because of the tension in the tugger line. More than 50% of the case is a failure for SBM, and around 35% of the case is a failure for EDF. We have a high differences between the TLP and the semi-sub because the tugger line modeling is different in each software that we use. So to summarize, the overall success rate for the case 1 without tugger line is 30% for the semi-sub and 25% of success for the TLP. And when we added the tugger line, we have slightly improved the result by 4%. We know for this case that there is still room for improvement, particularly in controlling the package motion. The possible adjustment that we could do in our simulation is the design of our tugger line. We could also extend the crane wire to shift the pendulum period. We could also change the position of the crane on the vessel and also choose another type of crane. Because we choose a straight crane, we could choose a knuckle boom crane. So based on our numerical result in this project, we also wanted to determine the operability of this system at specific sites. So here we have calculated the annual feasibility percentage for AO6 by vessel heading direction. So we can see that for Gulf of Lion, the highest operability rate it's when the vessel faces southeast or northwest, which is the predominant wave direction in this site. So given this position, let's have a closer look to the scatter diagram for this position, and we will see how we have calculated the operability percentage. So the operability percentage calculation cross-reference simulation result that we have done with the site's scatter diagram, and we have added up all the green dots percentage, which represent a success case. So all the plot here represent the Gulf of Lions wave occurrence for each direction over the year, and the darker area indicate a high occurrence rate. For Gulf of Lions, it can go up to 8%. So on each plot, the y-axis represent the TP and the x-axis represent the TP and the y-axis represent the HS. So for this direction, we have noticed that we have a differences of 7% in operability between EDF and SBM. To better understand the reason, we can have a closer look to the wave coming from 350 degrees. So for this direction, we noticed that on EDF side, we have 3 successful cases at higher HS compared to SBM. And this has boosted the operability by 5%. As you can see, it's written in green. This highlights the fact that the system positioning can really impact how we have calculated the operability percentage. So the other thing that we wanted to know in this project is the ideal operational window for Gulf of Lion, given one vessel heading position. You can go to the next slide. So with the vessel positioned southeast, we found that the feasibility percentage over the year for each month exceeds 70% throughout the year. So it make this operation highly operable for this direction for Gulf of Lion. So now we wanted to shift our focus to the South Brittany site, and we wanted to see how the conditions differ there. So for South Brittany, the results were really lower than Gulf of Lion, as it experienced higher HS and TP, which are a fail case for our numerical simulation. So here we can see that the most favorable wave direction are east and west, which align with South Brittany predominant wave direction. And based on this vessel heading east, we can have a look to the wave scatter plot for South Brittany to better understand the wave characteristic. So in this scatter plot, as for Gulf of Lion, you can see that in each plot, you will have the TP as the x-axis and the HS as the y-axis, and the darker area are marking the highest occurrence rate, which can be up to 6% in South Brittany. So compared to Gulf of Lion, we can see that the scatter plot for South Brittany reveals a distribution of HS and TP value that trends to a higher value. And now let's have a look on how the three cases that has passed in EDF has an impact on the operability in South Brittany. So if we are looking for the wave coming from 270 degrees, we can see that the three cases that has passed on EDF side and not on SBN has only boosted the operability by around 1.5% over the year. And now we will determine the optimal operational period for South Brittany. So with the vessel heading east, we have identified for South Brittany that the most feasible months are June, July, and August, with a feasibility percentage above 35%. So now to conclude on the operability study, we can see that we have a higher rate of success in the Mediterranean Sea because of the wave period, and also the optimized weather window are during the summer for South Brittany and during spring and summer for the Mediterranean Sea.